So we are talking about single cycle processors. This is the last example we did last time. So we have a data processing instruction, add R1, R2, R3. This guy is Rn, which is R2. That's why we have a 2. And this is Rm, so 3. They're going to go into A1 and A2. And this is, again, 4-bit. We're just calling for the name of register. Set name of register. Hey, register 2, you are up. Now we go in, take the content of register 2. So this is going to be 32-bit. And going into ALU, hey, register 3, you are up. Give me your content. I go into register 5, bring the content of R3, bring it in ALU. We add them up and put it into where? Our RD, which is 1. So the result is going to bypassing getting into WD3. So WD3 is going to be 32-bit. A3 input is going to be 4-bit. A2 input, 4-bit. A1 input, 4-bit. So that's data processing instruction example we did. These two lines goes hand in hand, right? If you have a RD, we need to update the contents of RD. We have to have a content to update. Therefore, either we have both or not both. So now when we look at the branch instruction, we use PC plus 8. When I need to execute any given instruction, I have a PC value. That's the instruction address. So go in here, take that one, and do it. Go through this data process and do it. At the same time, we have PC plus 4 going in here, and the result is going back to in here. That means while we're executing any given instruction, we already place the PC value into PC plus 4. So we know which instruction is our next instruction. And in here, PC plus 4 is going fit back into instruction memory, at the same time fit it into another ALU to get PC plus 8. PC plus 8 is going to store into R15. So in branch instruction, we need to have R15. It's not showing in here, but we'll show this here right there. So we have an option in this mux. Either we take 19 through 16 or choose register 15, which has PC plus 8 in it. This BNE L2, do it, copy this down. We have PC plus 8 in here. We're going to use register 15, whatever the value we have, and going into here, and then extend it, the immediate value, sign extended, and fit in here. And that's the instruction that we're going to execute next time. And this example is what we did before. Okay? So that's the 6.4. We have this example. We're going to follow this through. So this is the one that we are highlighting with this value. PC value is 8050, and PC plus 8 is here. And how many lines? 1, 2, 3, 4, 5, 6. So this is the branch target address. That's what we learned in chapter 6. Now, we're going to look at in here is actual PC values where we're taking into, and what are those actual values for each line. From here, this PC is 8050. That's our starting point. From this example, we're going to highlight this branch not equal to. If it's not equal, then go to L2 is here. But in the data path, they don't know where is the PC plus 8. They don't know where to go. So we need to use these numbers to show that exactly where to go. So that's OX8050 we got. So this is PC plus 4, PC plus 8. So when you add 8050 plus 8, 8058. And then we're going to select this box output as a 1 so that I can have register 15. Where is the register 15? Here. What is the content of register 15? 8058. That's what we store in here. So RA1, we want to call it 15. RD1, content of this RD1 should be now 8058. This PC plus 8 happening every single instruction, regardless of branch, memory, data processing. It's happening every time. There's no other path. So we're going to store PC plus 8 R15 every single time. Now, we need it, then we use pick 15. We don't need it. Data processing, we don't need this. So we're going to select 0. It's there, but we don't select it. So we update R15 every single time. Every single time when we execute any given instruction, we update R15. Now, it's just a matter of this instruction really need to use R15 or not. If it's the data processing, if it's the memory, we don't need that. So simply, we are not select this guy. For branch instruction, we need that. Therefore, we select 15. So whatever the value inside of this R15, we just update it as a 8058. That's going to be right there. Okay, let's do it again. So are we all okay with the PC as a 8050? Where we get this? From here. It'll be given. Based on this number, we need to calculate this number. So that's 8050. And I'm going to grab the instruction, and that instruction is this. And then I'm going to update PC plus 4 and waiting right there. And then at the same time, PC plus 8 is right there. 8050 plus 8, 8058. So what is 8058? Exactly PC plus 8, where we store it. Register 15. That's the number we need to use it. So that is stored there. That's why we call, instead of putting any other number, we need to get content of register 15. So I'm going to call it this 15 right there. That way, I can bring contents of R15 to here. What is the content of R15 we said? 8058. Now, these values extended, we have FFFA. That's what we had in this instructions from previous one, right? So we're going to feed in FFFA in here. It's a sign extended 24 bits. You want to copy down. So I just write 11111010. That's FFFA. We should have 8 more ones in front of these ones. That's what we're going to feed in here. And then once you get into this, watch here. Watch here. Once you get in, fit this guy into extended, we said sign extended unit for the branch. What do we do? Shift left by 2. We need to shift this guy left by 2. Then we have 2 more zeros at the end. That'll give us negative 24. Negative 24 in hexadecimal is what? 16818. So you subtract 18 from there. It's going to be 804. Where we go after we execute this? Where is L2? Right there. What's the PC value? 8040. That's how we calculate this. So in the branch, we have to shift to the left by 2, meaning multiply by 4. Again, it's a byte addressing. One word is 4 bytes, so we need to shift left by 2. So next instruction we're going to execute is going to be 8040.